Thanks, Peter, and good morning, everybody. It's an absolute delight to be part of Technology One Showcase. We are living in a time of absolutely massive changes to human society. We've got geopolitical events unfolding, the likes of which we haven't seen since the 1960s. Climate change is happening, population growth is happening, and of course in the technology world, things are accelerating at an ever-advancing rate. Not only that, but we have the convergence of medical technology and tech, and maybe even taking it into our bodies and changing what it means to be human. Now, the pace of technology has been doubling every 18 to 24 months for a really long time now, but we're at a stage now where we're at a high level of technology and we're starting to go up a curve like this. And because of that, there is a disconnect between what people think is going to happen with automation and what economists and many others are predicting. Around the world, if I look at research reports from think tanks, anywhere from 40 to 50% of today's jobs are likely to be impacted by automation. Yet in surveys around the world, people don't think that automation is going to impact their careers. In Australia, earlier this year, Randstad did a survey, and what they found was that 84% of the people they talked to thought that automation was not going to impact their job. Last year in the US, Pew Research did a similar survey, and they found that 80% of the people that they surveyed thought that their job would be unchanged or substantially unchanged for the next 50 years. Can you imagine? 50 years. But 2/3 of those same people thought that automation or robots would take over other people's jobs. So clearly, head in the sand, it's going to happen, just not to me. So many people have a doom and gloom outlook on what automation is going to do to our lives. I don't share that view. I see tremendous opportunities. There are going to be so many new jobs of the future, it's unbelievable. There's going to be data sets generated by technology that are just massive compared to what we have today. But it's going to involve changes and reskilling and being able to take all of this information and do something meaningful with it. So this morning, I'd like to take you on a little journey into the future and talk about some of the emerging technologies and how they're going to impact a wide array of vertical industries and each and every one of your lives. So let's start by talking about cities of the future. And there are two really big things that are going to impact city life. One is population growth, and the second is technology. So with population and cities, if you can believe it, in 1800, only 3% of the world's population lived in cities. By 2010, this had risen to 50%. Forecasters estimate that by the year 2050, we're going to see 70% or more of the world's population living in cities. And just about a week ago, I saw a report about Australia where they were estimating that 89% of Aussies would be living in capital cities by the year 2050. That's incredible. It's actually kind of insane because if we look at cities, they account for only 2% of the planet's landmass. So some things have got to change. One of the things that is already starting to happen is a race to build taller and taller buildings. And in fact, it's happening in Asia and in the Middle East. And along with taller buildings, you need faster and faster lifts. The Shanghai Tower in China recently won a Guinness World Record for the fastest lift. Their lift can go 127 floors in about a minute. It goes at 74 kilometers per hour. We're getting near to the speed where you'd have to actually have a pressurized cabin if it went much faster. On the way down, they actually have to slow the lift because if you went down at 74 kilometers, especially in a glass tower, you'd probably lose your lunch. There are companies like ThyssenKrupp that are also looking at technologies like magnetic levitation to use for lifts that go sideways as well as up and down. Technology is going to play an ever-increasing role in cities, and I'm sure most of you have heard the term smart cities. Whether I'm talking about things like smart parking, where in the very near future your car will be able to navigate to where there's an open parking space and actually negotiate the rate that you pay and reserve it for your car to park. I'm talking about things like smart trash bins, where instead of trash trucks coming around and emptying a bin just because it's Thursday, only coming around when the bin has a certain amount of garbage in it. In the world of industry, we're starting to see sensors deployed in really interesting ways that are saving a lot of money. In Italy, Trenitalia has deployed all kinds of sensors on their trains. And rather than doing scheduled maintenance, they're now starting to take inputs from the sensor data, use advanced predictive analytics, and do maintenance only as required. They spend in total about 1.3 billion euros a year on maintenance, and by taking this approach of using smart data from sensors, they are estimating that their annual savings will be in the order of 8 to 10%. That's a lot of money. There's also some really innovative and interesting smart city sensors that are being deployed. Here's one from my hometown of Sydney. It's called Mousetrap. This sensor is able to sniff out graffiti or permanent ink. As soon as it sniffs the ink, it triggers a CCTV camera feed back to police and to the train office so that they can see in real time what's going on and be able to catch perpetrators of graffiti in action, because they're on a moving train and they'll get them at the next stop. Graffiti on these trains cost about $34 million a year. The investment in Mousetrap was about $500,000. You can see the return on investment very, very easily. Another really cool smart city project that you may not have heard of is called the Array of Things, and it's being rolled out in Chicago. It's supported by a grant from the National Science Foundation of about 3.1 million US. And what they're doing is mounting a wide array of sensors on light poles throughout the city of Chicago. They'll end up with 500 of these by the end of 2018. They've already rolled out more than 100. So what these sensors are able to do is measure things like temperature and pollutants and vibration from traffic, pedestrian traffic, vibrations from heavy vehicles, and all sorts of other information. And they're taking it into a data set that they are making open source so that anybody can analyze this data and design applications that are truly useful. So let's say you want to take a late night stroll home and you have allergies. Well, there are two things that you might want to look out for. One are dangerous neighborhoods, so you'd want to know where there are other people around you. And second, pollutants, because you don't want to walk in a path where you might have an asthma attack. Apps are already being thought of that allow people to be able to take advantage of the fact that you're going to have block by block information. They're reckoning it that it's going to be like a Fitbit for the city. Or imagine you want to buy a house and you want to make sure that your house is in a quiet neighborhood, not affected by heavy traffic, so you'd want to look at vibrational noise. The sorts of things that you can design with this wide array of data is literally limited only by your imagination. We're going to see robots everywhere. If I were to tell you that there are already autonomous robots working on the Sydney Harbour Bridge, would you believe me? Well, meet Sandy and Rosie. These are two working robots that are doing inspection and grit blasting on the Sydney Harbour Bridge. It came out of a 7-year collaboration between the New South Wales Roads and Maritime Department and University of Technology, Sydney. And they got together because they wanted to try to address a problem that is a real problem for steel infrastructure like the Harbor Bridge, and that is it rusts, and you need to actually do a lot of maintenance and grit blasting to keep the metal safe and in good condition. But there are a lot of spaces that it is impossible for a human to get to or really dangerous for a human to get to. So what the engineers and department decided on was to look to nature to see how can we have a robot that biomimics the sort of movement that we see in the natural world. So they designed this robot called Croc that is based on an inchworm, and it is completely autonomous. It's able to get into all kinds of crawl spaces. It has real-time cameras that are feeding information to the bridge engineers and getting stored in GIS systems. The engineers are then able to assess whether grit blasting and painting is needed, and then the robot is able to carry out those tasks if required as well. This morning, you heard about self-healing software. Well, how about self-repairing cities? Imagine a city where potholes were an ancient memory, something from the Dark Ages. In Leeds, in the UK, there are a team of scientists at the University of Leeds that are designing fleets of tiny robots that will, in effect, design self-repairing cities. And the way that they reckon this will work is that these little tiny robots will be like the white blood cells in a human body, and defects in cities like potholes will be like viruses, and they'll go out and attack them. It's a collaboration between the University of Leeds, the national government, which gave them a very major grant, the Council of Leeds, and a number of other industry organizations. They're still in the robot design stage, but they've got 3 modes that they're looking at. One of them is perch and repair, where we'll have little drones that have manipulator arms that are able to do things like change street light bulbs, and maybe someday even be able to fix electrical wires. Another mode has to do with potholes, and what they're calling that is perceive and patch. In other words, get to a pothole before it becomes a major problem. And when I was talking to the lead scientist on the project, I was wondering how they might go about detecting potholes. One of the ideas that I came up with was, well, would you have drones just flying across the roads and monitoring what's happening and then send out a little robot to fix it? And they said, no, actually, what we want to do is collaborate with industry, because we're going to have driverless cars with tons of sensors and cameras. We want to be able to get the data from driverless vehicles, be able to then see in real time where there are problems brewing, and then send out the little tiny robot, which may have a 3D printer on it that 3D prints asphalt or whatever other material you need exactly when and where you need it. An even more ambitious mode that they want to do is have tiny little robots that are able to go deep under the city into utility pipes. And they're looking at a couple of different things here. One may be swarm bots, little tiny robots that each have their own brains or CPU that can attach and detach in all different ways, just like the Transformers do. Another thing that they're looking at is origami robots that can unfold or fold, much like origami paper structures can do. They've already designed and have in use borehole robots that I'm showing here that are able to do inspection in city pipes. And this is the same team that designed the exploration robot that went into the air shafts of the Great Pyramid of Giza and saw writing that hadn't been seen by human eyes for thousands and thousands of years. You heard earlier about a project at Tech One where interns were looking at augmented reality to be able to literally use smartphones to look through cement and see where pipes are. Well, in industry, augmented reality is going to be absolutely huge. By 2020, I've seen estimates that the AR segment in business could be a $100 billion US industry. Another cousin technology is virtual reality, where literally you're immersed in a virtual world. already industries are starting to use these technologies in their real operations. These pictures are from a water treatment plant in Spain from Acciona Agua, and they're using both virtual reality and augmented reality. With virtual reality, they're using it to train their staff on how to use all sorts of sophisticated water treatment systems and subsystems. With augmented reality, what they have done is equip their staff with HoloLens glasses so that when they're looking out at pipes or any other piece of asset infrastructure, they have cameras where they can collaborate in real time with staff in the home office. But essentially what they have is a real-time view of the SCADA system from the water treatment plant. And they're able to see things like what's in a particular pipe, what the temperature is, what the pressure is, or a digital overlay in which way to turn a valve. Virtual reality is also being used by industry for training. This is a picture that's taken in the Boeing plant in Philadelphia. And what they are doing at this plant, amongst other things, is painting and repairing Chinook helicopters. Now, traditionally, they would teach people to paint using real helicopters. But what they've designed is a virtual reality simulation where they've got a spray paint gun and nozzle, but it's not actually spraying paint. It just has the feel and the sound of a spray paint gun. And they're teaching people to paint these Chinook helicopters in a virtual reality simulation. And what they're finding is that when people graduate from this training, they're performing much better than they did with traditional training because you're also involving muscle memory in the training and you're not wasting any paint. Again, we're going to see a lot of examples of using these kinds of technologies in industry as well as in the leisure area. So let's talk for a moment about robots and jobs because it's something that's on everybody's mind. When it comes to automation, whether with a physical robot or a piece of software that's an AI bot, there are a number of criteria that companies will look at. First is whether it's technically feasible to automate something either with today's current technology or with technology that is just about to come out. Second, what is the cost of automating versus the cost of doing it manually? You've got to have it make sense. Then there's the cost of labor and the scarcity of labor. Even if it's expensive to implement, if you can't get people to do a certain job and you need that job done, then it may well be worth automating. But it's not just about replacing people. It's also about getting additional insights and productivity from the wide array of sensors that can be mounted in things like robots in conjunction with automation. And here I'm thinking of industries like agriculture or mining, where in agriculture, you might have a robot that's able to detect soil conditions, pests, fungus, nutrients, the stage of ripening of plants, and all sorts of things that you wouldn't get from a human being. And that starts to have a multiplier effect. Regulation is another thing that is going to impact the automation space, particularly with things like driverless cars. If it was made illegal to have a driverless vehicle in New Zealand, guess what? You wouldn't see driverless cars on your roads. On the other hand, if the government decided that certain lanes in highways were only for autonomous vehicles, you'd start to see a bigger uptake. And then there's social acceptance. How will people respond to automation and to robots in particular? Is anybody here a science fiction fan beside me? Raise your hand. Maybe a few, okay. One of my favorite authors when I was a little girl was Isaac Asimov, and he wrote about robots at a time before robots were a reality. And in one of his stories, in the far future, 1,000 years from now on Earth, We've crowded into these big cities. We're under domes because we've managed to pollute our planet pretty horribly. And we've got robots, and they're taking away a lot of jobs. And they're not very smart. They're smart enough, but not really, really human level intelligence. And you get a bit of robot bashing. At the same time, in the same time period, humans have gone extrasolar and started to inhabit other planets, and they've taken robots with them, and those robots are much more advanced. In fact, some of them are humanoid, and in one story, a woman actually married a robot. She fell in love with it. So you've got this spectrum of social acceptance ranging from robot bashing all the way to maybe falling in love with robots. The first place that you'll probably see a robot is in your vehicle. Does anyone here have a self-parking car? Anybody? Raise your hand. Anybody have autopilot cruise control where instead of having to take your cruise control on and off, you actually back on and off with the robot? Well, that's a robot driving your car. They're already available in today's models cars. We're going to see cars with all kinds of sensors that will put your car in either semi-autonomous or completely autonomous mode. And by 2020, 2021, pretty much every single auto manufacturer on the planet will have an autonomous mode in their car. I was at CES in January and was talking to manufacturers from around the world, and that's very much on the plate of every one of them. Investments in artificial intelligence is on the plate of every single car manufacturer, and also electric vehicles and hybrid electric vehicles. And in fact, Spark New Zealand is doing something interesting in Auckland and Wellington with a trial where they're taking payphones and they're converting them into part payphone, part electric vehicle charging station. It's actually a pretty cool initiative. But it goes beyond just having a driverless car. This picture is something I saw at CES. It's the Mercedes Vision van. So you've got a robotic cargo loader, and you've got a human still in the car, a driver, but you've got drones on top. So what happens is this is loaded up with packages. The driver delivers some of the packages, and the drones deliver other packages simultaneously. 50% improvement on productivity. Another example that Mercedes is looking at, another variation of this, is instead of having flying robots, having little ground-based bots doing deliveries as well. And with the ground-based bots, they're estimating 120% productivity improvement. So basically, you'd have this van acting like a mothership in a neighborhood, and you'd have bots and people going out and delivering packages. Already in Nevada, it's legal to drive autonomous trucks. You still have to have a person in the van, but that person can be looking at email or watching a video. And how long do you think it will be before somebody decides, well, why do we need the human in the cab if they're just watching a video? And in trucking, there are actually some dangerous situations where you want a human, but if they're playing with email or watching a video, will they be able to actually react in time? McKinsey estimates that in 10 years, 1/3 of all long-distance trucking will be autonomous. And I think that's about the right time frame. And the reason being is that these are very expensive assets, and you're not going to just chuck them out because there's a newer model that's available. You're going to chuck them out when it's time to turn over your asset and it's reached its end of life. One of the things that we need to be able to have both driverless vehicles and autonomous robots and augmented reality that we can trust reliably in business is accurate positioning information. And there's a super exciting project that's happening in Australia and New Zealand, the National Positioning Infrastructure Initiative, that is looking to take GPS accuracy for the mass market from between 5 to 10 meters down to about 3 to 5 centimeters. Once you start to get to that level of accuracy, then real driverless vehicles start to become a reality. Having augmented reality feeds from your SCADA systems suddenly mean that you're looking at what you should be looking at. This is a space-based project that is already starting to go live. In June, they turned on one of the satellites, a feed from a US satellite, and in October, they were planning to turn on a dual frequency version of this from Inmarsat to basically do space-based correction of the signals of the satellites to be able to triangulate to much greater accuracy. So if you can imagine, suddenly you've got information in your cars or your robot or your AR glasses that you can feed into your GIS system and then start to take additional action within your company. We're going to also see the emergence of vehicle-to-vehicle communications. And here, I'm talking about sensors in cars that talk not just to each other, not just to themselves, but to each other and to infrastructure. So traffic lights will have sensors that will say, I'm green and I'll be green for another 5 seconds. Speed limit signs will be broadcasting what the speed limit is in a zone. You'll no longer need to rely on robot vision to be able to determine what the speed is. This is a huge new business opportunity. Another really cool thing in the future will be hyperloops. How many of you have heard of hyperloop? Anybody? Raise your hand. Yeah, a few. So basically what you're doing is you're taking this big tube and you're sucking out the air so that it's at near vacuum, and you're hurtling either pods of people or cargo through it at super fast speeds. It was something that came up that Elon Musk dreamt up in 2012 and then published a paper in 2013 and open sourced it. And there are a number of hyperloop companies that have been developed. This is a picture from Hyperloop One's test track in the Las Vegas desert area. And they're already doing testing of this, and so far it's been successful. One of the pre-orders that they have is in the United Arab Emirates. We're taking an hour-and-a-half drive between Abu Dhabi and Dubai and reducing it to 12 minutes. In the US, there's a concept that's being looked at to put in a hyperloop between Washington, D.C., Baltimore, Philadelphia, and New York City, and bringing that drive down to 29 minutes instead of 5 or 6 hours. In Australia, they're looking at potentially having a hyperloop going between regional areas along the East Coast. Imagine getting from Sydney to Newcastle in 10 minutes, or Sydney to Canberra in 17 minutes, or Canberra to Wagga Wagga in about 8 minutes. You can see how something like this has the potential to really revolutionize what it means to live in a regional area, not to mention work in a CBD area, but live somewhere that is a lot less expensive. We're going to see flying robots or drones in all shapes and sizes, and inevitably they'll have cameras. They're already being used for insurance assessments when there are bush fires or floods. They're being used for asset inspections by telecommunications companies and by electricity and gas companies. There's even a flying defibrillator, this little yellow one on the bottom, that was designed by students in the Netherlands. And what happens is it hones in on somebody's GPS signal when they call emergency service. It can get there faster than an ambulance, so it can save someone's life when they're having a heart attack. And it's got a defibrillator on it and AV link. And as soon as it gets there, someone who's not a doctor or a nurse is taught how to put that defibrillator on and change someone's lives. One of the coolest drones that I saw is this one on the bottom right, and that is the world's first flying taxi, and it's called the EHang 184. I saw the prototype, which is working at CES. It's completely autonomous. It flies at 100 kilometers per hour. It has a 23-minute flight time, but it can only carry about 220 pounds in total. And this is not the only flying taxi that's being worked on. Uber's working on them, Airbus, and a range of others are working on it. It's like something out of the Jetsons. You know, this is like science fiction come to real life. We're going to see robots everywhere. In this picture, I've put together a little montage. Going clockwise from the left, that's actually a construction robot. It's called SAM, Semi-Autonomous Mason. When I first looked at it 2 years ago, It was able to lay 1,000 bricks per hour. By comparison, a typical bricklayer will lay 300 to 400 bricks per hour, and a master mason maybe 700 to 900 when they're really cooking. Today, this robot is able to do 3,000 bricks per hour, but that's nothing compared to a robot in Australia called Hadrian X that's able to do, I'm sorry, did I say an hour? I meant to say a day with Sam. Well, Hadrian X is able to do 1,000 bricks per hour and go 24/7. We're going to see lots and lots of robots in warehouses. This is from Locus Robotics, but it's just one of many. In fact, Amazon already has over 47,000 robots in their warehouses, and they are putting out more and more all the time, but still hiring people. In China, there's a restaurant that's staffed by robots. You walk into the restaurant, you get greeted by a robot concierge. In the kitchen, you've got robots that are doing stir fry and making dumplings, and then robots deliver you your food on a tray. In San Jose, there's a hardware store called Orchard that has a robot called Oshbot. And let's say you walk in and you need a widget that looks like this. You hold it up to the robot, it'll 3D scan it. On its faceplate, it gives you images of which one do you want. You tell it which one you want, and it trundles over and takes you to the exact spot. And it has digital signboards on the back. And if it had facial recognition, which it doesn't yet, or demographic recognition, it could actually target ads based on who's in back of it. Is it a family or a tradie or somebody else? Robots are real. There are robots that are being used in water inspection. This is one from Hibot, and it's really cool because in the US, let's say San Francisco, for example, they have about 1,200 miles of distribution pipes, and they have to replace a lot of these every year, but it's almost guesswork as to what pipes need to be replaced. So what they're doing is when a pipe is replaced, they don't actually physically take it out of the ground, it stays in situ. This robot goes into the old pipe, and it has cameras and electromagnetic detectors and soil erosion detectors, and it's able to figure out what exactly was happening in that decommissioned pipe under the ground to help figure out where the next pipes that need to be replaced are. In other words, using advanced predictive analytics. Hibot's doing some other interesting things. They've designed this snake-like robot that was used in the Fukushima disaster. And this is actually the next iteration. So it's a soft robot. It's about 8 meters long, and it's got cameras at the front and in the back, and it moves along using brush-like hairs, and it goes at a fairly slow pace, but it's used for disaster recovery. One of the things that they found in Fukushima was that the robots, these snake-like robots, were running into obstructions, and then they just came to a stop. So what they've designed in at the head of the snake are air jets. So you blast, and then the head raises, and then it just goes over an obstruction. So we're starting to see some cool stuff in robots. How many people like giant robots? Has anybody seen that movie Pacific Rim? You know, with the giant robots fighting monsters? Anybody? Raise your hands. Okay. Few of you. I've always been into robots. Well, these red things here are giant robots that were designed out of the Australian Centre for Field Robotics in conjunction with Patrick. And they're called autostrades. They weigh 60 tons, and they're able to lift cargo containers that also weigh 60 tons. So these machines together weigh 120 tons, and they've allowed Patrick to have autonomous ports in Port Botany and in Brisbane. The project actually started all the way back in 1997. Patrick's revenue went up during that period from 100 million to well over $1 billion, and they attribute 20% of that revenue growth due to the automation that they're using. Oops, this is just not going. Okay, oops. I wanted to just talk for just a moment about artificial intelligence. And when I talk about AI, I'm really talking about a whole range of different technologies. And I'm talking about things like machine learning and deep learning, natural language processing, emotion detection, facial recognition, image recognition, chatbots, smart robots, a whole lot of things. In the early days of AI, The approach was to try to take an expert's decision tree and mimic what the expert was doing and then put it into code. That started to change in 1980 with machine learning. With machine learning, what is happening is that you're feeding the algorithms data, and then the data is starting to inform what the software does. But in the early days, you still had to program in a whole lot of things, like to recognize a stop sign, you'd program in the shape of the stop sign. That started to change in 2010 with a technique called deep learning, where the AI was literally able to start teaching itself. And by doing that, you're feeding it more and more data. One of the early milestones was in 2011 when IBM Watson won the game of Jeopardy. So basically, it mastered all kinds of trivia in natural language and was able to win. In 2015, there was another really interesting change, and that was using parallel processing special chips to allow very, very rapid iteration of decisions in building really big neural networks. And in 2016, Google's DeepMind won 4 out of 5 matches of the game ago, a pinnacle of human creativity. One of the things that will impact many of you in the audience is robotic process automation. And that's a subset of AI where literally you're able to mimic anything you can do with a keyboard and a mouse, whether it be opening emails and attachments, reading and writing from databases, scanning social media for trends. In the world of finance, being able to do things like general journal ledger entries or reconciling accounts or even doing audits. In legal firms, there's already a bankruptcy AI called Ross in the UK that is pouring through thousands of documents, distilling down the information from all these documents into the likely cause of why a company went belly up and feeding that information to lawyers. This kind of automation is going to impact a lot of white-collar jobs. We're also going to see massive opportunities for AI in the training industry. And one of the challenges in training is that different people learn in different modalities. Sometimes you learn by reading, others by visualizing, others by doing. Imagine having content that you could repurpose using technologies like augmented and virtual reality for the way that a person learns best. And not only that, once you start to work with a person to drill down on where their skill sets need enhancing and use different techniques to help people learn. And not only that, but by being able to scour all the things that are happening in the world, keep that content up to date. We're going to see all kinds of chatbots used in industry. Already in Australia, UBank, which is a subsidiary of NAB, has deployed a chatbot for home loans, and it trained it on real conversations between humans and people in their call center. So now you can actually use this chatbot to apply for a home loan over breakfast really quickly. And they're looking at adding voice recognition and also emotion detection so that they can detect by the words you use and the language you use whether or not to have a human intervene. Speech recognition is another really important aspect of artificial intelligence. How many of you on your phones use Siri or OK Google or Cortana? Anybody? Yep. Anybody have a home assistance device like Alexa or Google Home? Well, guess what? These machines are always listening and they're always recording. And you've got to be aware that there are some privacy implications to this. By about 2020, it's going to be really common to see digital assistants on our devices, and they're going to be really smart and they're going to have access to all kinds of information. But we want to be aware of who's using that information, how it's being stored, and who's got access to it. So one of the jobs of the future that I think is going to be important is a privacy guardian, both on an individual basis and on a company basis. So if you can imagine on a company basis, there are some really severe penalties for privacy breaches. And not only that, but if you're hacked or breached, your stock price is going to go down by at least 5% or maybe more. But imagine that you've got staff that have these virtual assistants on their smartphone, and it's sitting in their handbag or their pocket, and it's always on, always listening, always recording, and you're in a board meeting talking about a potential merger and acquisition that hasn't been announced to the stock market yet, and somehow that data manages to get out there. Companies need to think very carefully about what this is going to mean. So many more jobs of the future, and I'm not going to have time, I think, to go into all of them in great detail. But one of them that I think is going to be really important is the head of human robotics and head of orchestration in human robotics. And with this job, it will be looking at whether you use a person, a machine, or a piece of software to do any particular task. But more important, how do you take real-time data and enable an organization to act on things that both your people, your machines are detecting in real time? Another job that we'll see is an AI trainer. And there are some weird and wonderful things that happen in AI building big neural networks. There was a report published by OpenAI a little while ago where an AI was doing boat racing. It was learning how to play a video game, and the objective was to cross the finish line with the most number of points that you possibly can. And instead of crossing the finish line, the AI got obsessed with actually winning points, and it did everything except cross the finish line. It went round and round in circles, crashed into other boats, crashed into other walls, never finished. What the researchers determined was that we actually need to add a level of reinforcement learning and have humans in the loop. Much like we teach little kids, we need to teach our AIs to be good citizens. We also need to teach our AIs and robots to have heart feelings, empathy, compassion, feelings, and to interact with us in a more human-like fashion. And already companies like Amazon and others are hiring philosophers and poets and others with liberal arts backgrounds to start teaching these kinds of skills to the AIs that are being developed. Ethics is going to be very important as well, because when it comes to AIs, especially with really big neural networks, it's not always clear exactly how a decision is being made. An example is out of the US in the criminal justice system, where there's an AI that's looking at the potential of recidivism. In other words, whether a criminal should be given parole based on whether they're likely or not to recommit a crime. And there are 137 factors that were fed into this AI. None of them had to do with race and ethnicity, but the AI was consistently being more lenient to white defendants than non-white defendants. And it's really perplexing to the AI researchers. I have a theory, and that is that the AI was looking at the documentation that follows a criminal through his or her career and picking up on unconscious social biases. As we start to put AIs into our business, we're going to need chief ethics officers who look at the inputs and outputs and make sure that they're actually congruent and that we're using AI in a way that a human would make a decision. So going into the future, are we going to see technology in our bodies? Well, probably. And it will most likely start with smart contacts. This is on the 5 to 7 year horizon, already in the research lab, combining ICT, augmented reality, and biotech. So if you can imagine having smart contacts and looking out on this audience and knowing everybody's name, how cool would that be? Or getting your navigation directions. Well, Google, Sony, and Samsung already have patents where they have cameras built into these smart contacts where you blink and you start taking a picture or a video. The big picture that I'm showing you here is from Google in 2014. The littler picture is the same lens in 2016. By the time this comes to market, these lenses will be completely translucent. They'll probably be made out of graphene. It's this amazing material that's harder than diamonds, harder than steel, but it's extremely bendable and flexible and one of the thinnest materials we know and a great conductor of electricity. Where it gets fascinating, though, is the biotech side, because the pharma companies are looking to also introduce things like autofocus. So I need reading glasses. I could ditch my reading glasses because I'd autofocus. And why not get telephoto and infrared as well? And it turns out we've got a lot of chemicals in our eyes, like lacriglobin, which can detect our insulin levels. Imagine that you need to take prescription medicine and you take it every 4 hours just because that's what's on the label. Imagine if these contests could actually measure the level of drugs in your body and tell you through an augmented reality heads-up display, it's time to top up. And you actually take the drug when you need it, not just because it's on a schedule. Going further into the future, well, we might even have neural interfaces directly in our brain connecting us to the World Wide Web. Ray Kurzweil thinks that we might have 3D printed DNA robots that connect directly into our neocortex. Imagine thinking a question and getting the answer right into your brain, or needing a new skill and downloading it, or streaming it, or sending a message brain to brain. And oops, hope you don't do it too fast. Not to mention the medical technologies that will come along with it. So there's so much to think about in the world of tomorrow, but the one thought I want to leave you with is that when it comes to automation, you really want to work with your people about what tasks are repetitive, what can be automated, and how can you better use your time. Start looking at jobs of the future and skills assessments and reskilling your staff rather than laying them off. If you do that, then we're going to end up with a wonderful future rather than the robo-apocalypse that so many people are talking about. Thank you.